guys, are there any questions over any of the assignments so far?
35 on yesterday's.
Yes. 35 from yesterday.
I couldn't figure it out. Because I ended up with e to the 4 on one side. I didn't know what to do with it.
This one here?
Yep.
So, whenever we have two logs being added together, we can rewrite it as multiplication. So we can say ln of x times x plus 3 is equal to 4. And this one is, now that I'm looking at it, I do remember this one. And it's a little funny how this works. The next thing we can do is apply e to both sides. These cancel, telling us we have x times x plus 3 is equal to e to the 4th power, yes? On the left-hand side, when we multiply it out, x times x is x squared. X times 3 is 3x is equal to e to the 4th. Anytime we have a degree greater than 1, we've got to get everything on the same side. So we'd subtract e to the 4th from both sides, telling us that we have x squared plus 3x minus e to the 4th equals 0. E to the 4th is just a number, yes? It's an irrational number. It's not a nice number, but it's still a number, yes? So we have to use quadratic formula for this one here. It's odd because this is not something you would normally think of, especially with e to the 4th. But given that it's just a number, we can just plug everything in. So our value of b here is 3. So we'd say negative 3 plus or minus the square root of 3 squared minus 4 times a times b, or sorry, c, which would be our negative e to the 4th, all over 2 times a, which is just going to be 2. Now for this one here, we do have the two cases with the plus or minus with our square root, yes? Is the number that's going to come out of that square root going to be a nice number? No. Radicals, unless it's a perfect square, do not give us nice numbers. And well, we already have an irrational number inside the radical to begin with. So this here is not going to work out to be an overall nice number. So what we can do is we can grab the calculator, let it load. Okay. So what we can do here is say alpha y equals enter. So negative 3 plus second square root 3 squared minus 4 times 1 times second e negative second e to the 4th, close parentheses, all over 2, or 2 times 1. And we get 6.30 or 6.0397. If we go 3 decimal places, 6.04. Almost got it. Yep, 6.04. Comma. Now, instead of typing this whole thing back in, we can pull it back down because we do need to change one thing. Because the symbol in front of the square root is plus or. So we also have to do this with a enter negative 9.04. Is our other alternative, yes? But what are we starting out with for this here? We're starting out with the natural log, yes? And one of them is just the natural log of x. And whatever's inside the natural log cannot be 0 or to the negative 9.04 doesn't work. It is a solution, it's an extraneous solution, but it doesn't work for this here. Questions on this? 35. There might be one more that's going to make you do this here, but again, really getting down to the quadratic, just plug it into the quadratic formula and it'll give you your answers. Any questions on this here?
For some reason, when I plugged it in, I got 109 point something, but I must have just.
Let me see. Right here. Because it took all of that for e to the fourth. Well, I'm just going to change it to plus because I negative in. So, well, the negative e and the negative 4, the negative and negatives make a positive. Since I left the negative out, it's going to be a little bit of a challenge to just retype it. Well, I know that those are going to make each other positive. So sometimes we can do that there, like with the 3 in parentheses squared. If it had said been negative, well, the negative squared is going to become positive. So I could have just put 3 squared of that number squared because the negative will go away. So we can cheat and use some of those steps. Any other questions? We ready to look at today's? Today we have, I think it's 3 problems. These here aren't any different than what we did yesterday. We'll do at least 2. Because we talked about these yesterday, whenever we have 2 logs being added together, I can rewrite it as a single log being multiplied. If we have 2 logs being subtracted, I can write it as a single log where what's inside is being divided. Now everything's the exact same as what we did yesterday. So we need to put both sides to the same base, which would be 10. These cancel. $1,000. What can we do next? Yes. Because here the 2 and 2 will cancel out, telling us 3x minus 2 is equal to 2,000. Yes. Will 2002 divide by 3 evenly? No. Because any number divides by 3 evenly if the sum of its digits also divides by 3. So it would be what? 66.3 repeated? Or 667 and a third? Because 6 would give us 18. Yep. Either one works. Any questions on this here? Is this any real different than what we did yesterday? No. We'll do this one here and then we'll call it for today, because the one after it isn't any, actually it's not any different than what we're doing. It's the same thing as what we just did. We just have a variable in the denominator. So this one here, whenever we have two logs being subtracted, we can rewrite it as a single log where what's inside is being divided. Because whenever we use this bases, applying bases to both sides, we want both sides as simplified as we possibly can get them. So if we can have it as one term on either side, that's great. If not, I want all the variables on one side and anything else on the other. So even if on the other side it was 1/2 plus log base 4 of 30, that's fine. Log base 4 of 30 is still just a number. I've got variables on one side, numbers on the other. Even if it's logs, it's still just log of a number is still just a number. And again, most of the logs, there are some that work out nice, but most of them work out as an ugly decimal, yes? Personally, I wait till the very end to calculate it, because every time we round, it's going to get us farther away from the answer. Now, what are we going to apply to both sides? A base of 4, because these will cancel out, giving us x over x minus 1. 2. Because 4 to the 1/2 is the same as the square root of 4, which is 2. What do we need to do to get, or what do we need to do next? And it's not scroll. Yes. Because we need to get rid of that denominator, the bottom of that fraction. Because if I multiply the left side by x minus 1, we would actually get x minus 1 over x minus 1. Anything divided by itself is 1. So that simplifies out, leaving us with x is equal to 2 times x is 2x. 2 times negative 1 is negative 2. And then we would, what would we do next? Yes. There's a lot in me that really wanted to add the 2 to try to keep things positive, but we would have to add the 2, subtract the x, where just subtracting the 2x is a little bit easier, a little bit faster. Because if we subtract 2x from both sides, we'll get negative x equals negative 2. Or positive x is equal to 2. We could have divided both sides by negative 1, multiplied both sides by negative 1. But if I change the x from negative to positive, the other side has to change from negative to positive. Or really, if negative x is negative 2, so x has to be 2. Questions on this here? And we can look back to make sure. Well, if this is 2, 2 minus 1, will either one of these give me a negative or 0? No, so 2 works. Any questions on any of this here? And that's it. That's all we have to do for these here. Any question on anything we've done so far? I think on one of the assignments we've gotten so far, I feel like 10 to the 36 might show up as an answer choice. Leave it as that. Leave it as 10 to the 36. Because if numbers get this big, it's not helpful in solving. I mean, we could write it out. It is 1 undectillion. If you want to figure, because this probably surprises nobody, for any 10 to the n, if we're looking at this here, we can take whatever that power is, subtract it by 3, and divide it by 3. So 36 minus 3 over 3. Well, 36 minus 3 is 11. So 11 for this notation is undec, 110, and illion, because all of them we're talking about illion, because trillion is 3 illion. So billion is by illion. Million is my 1 million, my illion. But, so we have our normal 3,000, and then we have our first spot for million, yes? Well, if we minus 3, which leaves me with 3 zeros, divided by 3 I get, so it's million. Let's see if the eraser for that side. Now we're at 1 billion. Well, still subtract the 3, we have 6. 6 divided by 3 is by billion. And it works for most numbers. Interestingly enough, and I hadn't thought about this when I put this together the first time, 1/3 would be our, see here, hundreds, or sorry, tens. And if we get 2/3, it would be hundreds for the overall zeros placement. Because it seems odd why 1/3 wouldn't be ones, but here we already are in the ones, yes? So it's an even amount. So this here would be our 1/3, 2/3, because if we get to this spot here, we're back to the next whole number. So for any number, for a power of n, we can actually use this to get the name of what it is. It's completely useless, but there you go. And you have 33, 34, 35, 36, 37, a total of 5 problems. And that's all we're going to cover today. Tomorrow we're going to be delving into more inequalities with these here.